Great. Well, yeah, thank you a lot, Arvid, for inviting me, and thanks everybody for coming. I'm really excited to talk to you all about AI and machine learning project selection at Eastman. I'll do a brief introduction. I'm Bryce Curtsinger. My job title technically is a data scientist at Eastman. I've been here since 2019. I'll do a little bit more background here in just a minute, but I do want to talk a little bit just about why I chose this topic. A couple of reasons, really. One, sort of an interesting fact that I read recently. Gartner predicts that through 2022, 85% of AI projects.
Unmute yourself, Bryce. I hit your wrong button.
That's all right. Yep. All right. Excuse me. Why did I choose to talk about this topic? An interesting fact that I'd read recently, Gartner predicts that through 2022, 85% of AI projects will deliver erroneous outcomes due to bias in data, algorithms, or the teams responsible for managing them. So in other words, about 9 out of 10 AI and machine learning projects this year will fail. Being able to select the right projects will help you avoid failure. Additionally, I don't find too much value in exploring cool applications of AI or advanced machine learning techniques, even as a practitioner. Just because, if something worked for somebody else, it doesn't mean that it will work for you. And it's really not practical to anybody who's not an experienced machine learning engineer. But knowing how to identify the right projects, define success for them, and effectively deliver results is really useful for anybody who may engage in AI and machine learning projects, not just experts in the field. And just a quick note on terminology. So I might use the terms AI and machine learning interchangeably during this presentation. I will talk a little bit about one versus the other here in just a little bit. Just know that they are related to where I will use them in place of each other sometimes. Additionally, you might hear me use the term data scientist or machine learning engineer to describe a practitioner of AI and machine learning. Similarly, I might use subject matter expert or user to describe somebody who benefits from the results of machine learning. Your organization might have their own terms for each of these roles. So really just fill in that blank with whatever you think fits best for your organization to add context here. And today, I want to give just a brief overview of what AI and machine learning is. The previous video, I think, did a pretty good job defining that, but I'll just add a little bit of my own take on it as well. But really the meat here will be focusing on what makes a project suitable for AI and machine learning applications. And as part of this, I will discuss the Eastman project philosophy for how we approach these projects, the characteristics of identifying a good project, and how to set goals and deliver results from these projects. Finally, I'll wrap up with a couple of examples of where we've used machine learning at Eastman and kind of talk about why these projects were or weren't successful. And just a little bit of background on me. So I was born in Knoxville, Tennessee, home of the Sun Sphere and the University of Tennessee, which is where I earned my bachelor and master's degree in business analytics. I grew up near Holston Hills Country Club. I know I saw one person from Knoxville here, so if you know where that is, it's a beautiful golf course down here. Unfortunately, didn't appreciate golf as a child to be very good as an adult. But after graduating in 2019, I joined Eastman's business analytics department. And later that year, I moved into the AI and machine learning group. And then right before the COVID-19 pandemic in 2020, I moved back to Knoxville and began a remote career with Eastman, which I've been doing since. And as Arvid mentioned, today was actually my first day back visiting the office in about a year. So I do have a small family here in Knoxville. I live with my wife, Ellie, and our 2 cats, Scrod and Ozzy. And just to put a little more human behind the screen that I'm speaking to you through, Outside of work, I enjoy many of my hobbies, which include remaining active through weightlifting, gardening, occasionally fishing, and sport shooting. Unfortunately, I don't look like Arnold Schwarzenegger yet from my working out, hoping to get there one day. And to relax, I enjoy playing tabletop games with my friends, reading, drawing, and cooking. But with a brief introduction out of the way, I'd like to introduce the topic with a concept you may be familiar with, which is descriptive versus predictive versus prescriptive analytics. So we think of analytics in this context using a pyramid. So kind of like Maslow's hierarchy of needs, each step must be met before addressing the next. And just a little overview of what these really are. So descriptive analytics is things, just making data available to the right people so that you can see what happened. So this might be done through an interface like a dashboard, where diagnostic analytics is digging a little bit deeper to find out why something happened. So this might also be solved with a dashboard where one can draw their own conclusions, or through a more advanced statistical analysis to determine causation. AI and machine learning primarily answers predictive and prescriptive questions. So, once we know why something happened, we can predict what will happen. And then once we know what will happen, we can determine the right action to find some optimal outcome. And I mentioned dashboarding here as a way to make data available to decision makers. And just to clarify this concept, I've included an example of a dashboard that we created here at Eastman that actually monitors some of the applications that we've created. So, a dashboard's really just any way that a user could easily digest or interface with data. It might include plots like we have here. It could include, tables of data, just numerical summaries of performance metrics, really any written or visual summary of data. And it's typically just a way to share descriptive analytics, like I said before, but it can really be used at any stage in sort of that analytics pyramid. You might include a summary of last month's performance, a plot of key drivers for that performance, a forecast of next month's performance, or a recommendation of targets to meet next month's goals. Really, any visual interface that enables a user to gain knowledge from data could be considered a dashboard. It shouldn't really imply the use of a specific tool or software set. And so I'd like to move on just to talk a little bit about an overview of artificial intelligence and machine learning. And so artificial intelligence and machine learning, kind of as I already mentioned, tend to be used interchangeably. I often do it myself, but really we consider machine learning to be sort of a subset of this broader artificial intelligence umbrella, which contains machine learning and what is known as an intelligent agent. And to distinguish here, an intelligent agent is really just a machine that's designed to mimic human intelligence. It may be just programmed to respond to commands in a rule-based way. For example, as of writing this, Amazon Echo, it's suited for specific tasks and questions. So if you ask a question to Alexa and receive an answer, it's really been specifically programmed to provide that answer. Some cases might actually use machine learning. So an intelligent agent might use machine learning to better respond to commands like Google Home. So for example, if you were to ask Alexa, what time does the library open? Or Alexa, what time does the Kingsport Library open? She won't know that answer. But if you ask her, Alexa, what time does the Kingsport Public Library open? She will respond with the hours and the location. Google Home could just answer the question with, okay, Google, what time does the library open? And apologies if I've set off anyone's smart home devices during this presentation. But intelligent agents can also use machine learning as well, like I mentioned. Self-driving cars are a good example of this. To drive properly, a car has to be in the right environment. It has to have lines and be specifically trained to recognize what it's seeing. Encountering untrained obstacles like a pedestrian in an unforeseen location will not impact its decisions. On the other hand, looking at machine learning, so machine learning seeks to mimic human decision-making using algorithms and data to learn behavior. And it's really aimed at answering a specific task or question that's used to make business decisions or predictions, and generates insights from data that are not explicitly searched for. And similarly to intelligent agents, machine learning is also suited to a single task. And like I mentioned, you can often use these in combination with one another, where an intelligent agent may use machine learning to perform its task. And so we talk about machines learning to mimic human decision making, but there are different ways that a machine can learn. The typical way that we would train a machine learning algorithm is simply providing examples of the past. So the algorithm learns patterns from previous behavior and extends those patterns to predict future behavior. This is the typical approach for most machine learning problems, where the objective is to predict future values, like forecasting next month's sales, or answering a yes or no question like, does this image contain a hot dog? A newer approach to training machine learning algorithms is through trial and error. So the branch of machine learning known as reinforcement learning, it enables the machine to make decisions, often in a simulated environment or pre-informed by previous data. And then it rewards the algorithm based on the result of its decision. And this approach has been used to solve some really difficult problems, like self-driving cars. And if you've seen the 2010 film Tron Legacy, you might recall a scene where Jeff Bridges' character plays the game Go with his AI companion Quora. She mentions that she rarely beats him at this game. And this movie came out in 2010, and it actually took until 2015 until an AI that was trained with this method was able to beat a professional human Go player at the game. So this is really kind of changed how machine learning has worked, and opened up the opportunity to address some more difficult problems with it. So now I will go ahead and move on to talk a little bit more about our approach to machine learning projects and how we identify the right projects. So to address this problem, it's helpful to understand sort of our philosophy on a machine learning project process. So a machine learning project is a continuous circle which continues to live after the project in which it's created is ended. The project begins with an understanding of the business and the data around the problem. We work pretty heavily with subject matter experts to check our assumptions and to make sure our interpretations of the data are correct. We also have to consider if the data is in a usable state, and if not, what steps have to be taken to prepare the data. Then we begin by evaluating and creating and evaluating machine learning models, continually checking with subject matter experts for approval. Once the team's comfortable with the state of the model, we deploy it and move it into a maintenance phase. So in this phase, the subject matter expert can actually use our solution to generate value, and we ensure the solution continues to work as expected. And at this point, the project may end in our project management system, but the machine learning project continues. We like to take a Kaizen philosophy and consider the future of the project. Can we continue to improve our model, or are there new problems that we could help solve now that we've addressed the problem at hand? This philosophy has been really successful for us in ensuring that we create sustainable machine learning solutions, and create strong relationships with business partners. They help us identify new ways to create value with machine learning. So it's really beneficial for our data scientists to have a strong relationship with the people that they typically work with. So kind of with that understanding, let's talk about selecting and scoping machine learning projects. So the ultimate goal with machine learning is to acquire new knowledge, whether that be a more accurate forecast, when we need to stop a process for maintenance, or any other suitable problem. In any case, we hope to learn more than we previously knew using a machine learning algorithm. AI and machine learning is particularly useful for solving problems that are too complex to be solved by a human. This complexity could come in the form of having a large volume of data to consider, complex interactions within your variables that we can't easily see, or having many decisions that you have to consider simultaneously. Machine learning approach may also be favorable when you identify a problem that can just be daunting to solve manually. One might spend significant effort to aggregate and digest data to reach a decision where artificial intelligence could find a better decision in seconds. Even better if the same solution can be scaled to address many problems. It's really hard to overstate the value of addressing scalable problems with machine learning. And finally, consider if your problem is really an automation problem and you just think that it's a machine learning problem. If the process involves one or more repetitive tasks or hard-coded rules rather than learned rules from data, you should consider automating the process to see if that can solve the problem. And I guess talking about data a bit, there's a bit of a misconception that you need big data to use machine learning. In reality, the quality of your data is more important than the quantity. And so what do I mean by quality? It starts with making sure that the data contains examples of the cases that you're interested in predicting. So an interesting take that I'd heard on this from a consultant we worked with in the past is that predictive maintenance projects are often not successful because the process in question never experienced failure. So consider if your data will contain an explanation for the results that you hope to see. Second, we need clean, accessible, and complete data. So this boils down to making sure that you're capturing the relevant information at the right time, and that all necessary information is present in the data without external context. Finally, the data must be understood by a subject matter expert. So the subject matter expert should understand the data well enough to explain it to a data scientist and provide external context. And these last 2 points may sound contradictory, that the data shouldn't require external context, but you also need somebody to explain the external context of the data. And this is really addressing two different situations. So, a data scientist has to have some understanding of the data to use it in a machine learning model. We can't, on the other hand, explain that data to a machine learning model. Any information that we think the model needs to have must be contained in that data somewhere. So that's, all that said, having a large quantity of data can still be useful. It allows you to use more advanced machine learning algorithms like neural networks or other deep learning techniques. Large data set will also allow for a larger set of data to evaluate your model performance. So you're helping to ensure that your model can generalize well to new data. So moving on, I think it's important to talk about delivering results in the right way. There's a common IT philosophy called configure, buy, and build. We like to use this to kind of classify how we deliver the results of an analysis. And simplifying this philosophy, it suggests that if an existing tool can satisfy the need, configure it to do so. If we don't have the right tool, let's buy one. And if there isn't a tool available, let's build one. Our terminology is a bit different, but is certainly influenced by this philosophy. So to configure, if the problem we're addressing is already part of a business process with its own interface, we'll continue to use this interface if possible. This is typically the case where we're just trying to improve some existing process with machine learning. And the biggest benefit of this approach is limiting maintenance needs to the machine learning model built by the data scientist. You typically are limited in how customized you can get with the solution. For the next case of buying, we consider procuring an external solution with some built-in machine learning capabilities. For this case, we might complete a proof of concept internally to just demonstrate the value of the project, and then search for software that just streamlines the analysis and provides a user interface for our users to gain value from the project. And the data scientists at Eastman we're often involved in the purchase of new software that advertises AI or machine learning capabilities. We just want to help evaluate that their claims are true and make sure that Eastman is purchasing the right software for the problem we're trying to solve. I would strongly suggest adopting this practice as well if you don't already do so. Many companies might claim to feature AI and machine learning, which are often just not as good as they make it sound. But for when we do purchase these out-of-the-box AI machine learning solutions, we try to create an internal expert network, as we call it. So really, this is just power users of people who have been involved since we purchased the software, who use it regularly, and they kind of just form a group to help share tips that they've picked up from using the software and help onboard new employees or new users to try and use the application. And finally, if we can't configure or buy a tool, we will build our own solution. This building might be done by some internal IT professional, consulting company, or some combination of the two. This allows for the most customization in the solution at the cost of more resources that you have to dedicate to build and maintain the solution. We also add a fourth category to this list, which is what we would call a data scientist supported solution. Now, I kind of consider this a combination of all of the other three approaches, as it tends to use some solution that we pay for to host apps that our data scientists build that augment some existing business process. And for this, we typically use some combination of open source UI tools like R, or Python has some built-in app building capabilities, or we use a self-service visualization tool like a Power BI or a Tableau. And actually, most of our projects tend to fall into this category, mostly because it allows for a pretty reasonable level of customization in your solution. But you don't have as much development overhead as trying to build your own user interface. And it's certainly more cost effective than procuring a solution in the marketplace. This approach is also very effective for working through a proof of concept. We can pretty quickly prototype a user interface and get our analysis in the hands of users. And then if we decide to move to a more sophisticated solution for production, we already have a UI prototype that we could share with a developer once we decide to move forward with the project. And so we talk about software a lot, and the handoff of a machine learning project tends to often take the form of software. So it's worth talking a bit about what to look for in software. We discussed the different forms this can take on the previous slide, but here I'll just expand a bit on sort of the cost and things to consider once you've decided on a path forward. Of course, one of the most important considerations is cost. Is the value that we generate from the tool worth it? And there are many things to consider here. I'll provide my perspective on what we tend to look for in considering these costs. It's important to not only consider the price, but other costs that may be associated with it. So consider Excel. I'm sure that most, if not all of your office-based employees at your company might have access to Excel. So the price of a new Excel-based tool is essentially free, but there's other costs to consider. So, could you protect this tool from a user accidentally or even intentionally breaking it? And your Excel tool might rely on the VBA programming language, which is rapidly going out of style in the younger circle of business professionals. What's the impact if your tool is broken for some amount of time due to these or some other factor? And then on the other hand, dedicated software might be more stable and require less internal development, but can carry a price tag in the millions of dollars. So we find that a happy medium is often a good approach, where we have some software that streamlines the development of an internal solution, either by providing a platform for the users to easily access the data scientist results, or just providing a way to host some custom-built internal tool. These tend to offset the cost of an out-of-the-box solution by requiring just a bit more work on the user or the data scientist part. And some further considerations when selecting a software solution to use. So for an existing tool, is it something that your users and your data scientists are familiar with? If not, just consider the learning curve. Will it be easy for a new user or a developer to pick it up? Just think about the longevity of the tool. Is it something you expect to consider purchasing for the foreseeable future? And what's the cost of switching if you decide not to procure it again? And finally, whenever we're actually procuring software, we tend to consider if the company actually employs data scientists or some similar role. And do they include them in the conversation when you're considering the purchase of their software? Can those data scientists provide transparency about the algorithms and techniques they use? And this is the time where you should consider, bringing in your own internal machine learning experts to the conversation. And also just consider the ongoing support strategy for the software. A good company will likely offer ongoing support, typically decreasing over time as you become more familiar with the software, and you can, begin to onboard new members through your own network of users. And so finally, let's talk about setting goals and defining success for machine learning projects. So with our philosophy of the machine learning project process, we often take a MVP approach, or it's called the minimum viable product, whenever we set project goals. So for this, we consider what is the minimum that our solution would have to do to begin delivering value to users. So we find that, we set our goal, and we set a deadline for when each version of that product would need to be available to a user. So depending on the size of a project, you might have a number of different phases of these MVPs. And this approach really offers some advantages. It gets the product in the hand of users faster. So while it may not be finished, they're able to begin working with and gaining some value from the solution before we completely finish the development of it. They can also offer feedback for future iterations of that MVP if they have a chance to actually work with it. Those improvements, they might take the form of expanding your scope to cover more cases or include more data, improve the performance of the solution. And for each stage of that MVP, we set an acceptance criteria to specify what the features that we have to have included in that stage are for it to be considered finished. And in setting criteria like this, I would strongly encourage you to not set specific goals around model performance or accuracy. There's really no way going into a machine learning project that you would be able to guarantee the accuracy of a model and setting a goal to achieve, 90% forecast accuracy or less than 5% error doesn't really encourage the creation of a useful model. You should really set acceptance criteria around ensuring that the solution enables an end user to solve a problem. And so Eastman, we encourage taking risks and trying new things with the caveat that you fail fast if it doesn't seem to be working. So the MVP approach encourages this behavior through regular check steps with users and the stakeholders in the project, and getting the users' hands on it faster to get that feedback. And this is where it may be appropriate to consider your model performance and the success of a project. If you're seeing gaps in performance and throughout these iterations, you can't find a path forward to bridge the gap in performance between what you're seeing and what you're expecting, that's when it might be appropriate to pause the project. That might be the point where you say, is there data that we're missing? Do we need to go gather additional data or find some data that we just aren't including in the model? Ultimately, you just want to be able to recognize early on that if the solution cannot meet the user's needs, then you really need to pause and see if you can rectify that problem. Finally, we would recommend building a maintenance plan into your project goals. So specify, who's responsible for maintaining a machine learning model, and at what interval should they review the model to make sure that you're still getting good performance out of it and it's still generating value. There's some software that exists which could automatically monitor your model performance over time as well. And just more for the machine learning practitioners or project managers out there, we've identified from working on some projects, working where we're over 6 months on the same project. We've had some success building in a pause period into the project schedule. So this is where, if we're working on a project where we're rapidly expanding it and it's just trying to grow it and push it out to new areas, we find that taking a small pause, maybe a couple of weeks to maybe a month, depending on the span of your project, was really useful. Where rather than trying to grow the project or expand it out further, we just devoted time to fixing or enhancing the current solution. So that gives you the chance to see if the areas where you're already using the project and generating value, if you can even generate more value there or stretch that solution further. We also found this very successful in reducing burnout amongst our data scientists. If you're highly dedicated to the same thing for months and months, and it's just constantly a go attitude, it can be really nice to have a chance to stretch your brain and think outside of the box on a problem that you've looked at in the past. So it had a really nice bonus for us of keeping our team in good spirits as well. And so just to kind of summarize what we've looked at with how we approach machine learning projects and scoping projects, there's really just some key questions that you need to answer during the project scoping phase to make sure that well, for one, machine learning is the right tool for the job, and to help the project succeed. So, consider if the project's suited for a machine learning solution. Is there complexity around one or more decisions? Is the problem too complex to be solved manually? Also consider the state of your data. Is it high quality data that's understood by your subject matter experts? And just also think about how that data is created and stored. Is it automatically recorded, entered into some data storage solution that a data scientist or machine learning engineer could access? And if not, do you have a plan for regularly maintaining the data? It's also helpful to identify the necessary roles that you would need for a project. So, typically for a machine learning project, your minimum is going to be a subject matter expert, and a data scientist. But depending on the project scope and your own organization's IT and data science maturity, you might include other roles like a machine learning architect, a database analyst or architect, user interface developer. Think about the roles that you might be familiar with at your organization. Just consider, the state of everything going into the project, who you might need to pull in to see it through to completion. And finally, identify how the subject matter expert will use the tool to gain value. In some cases, it might be sufficient to, interface through Excel or some self-service data visualization tool in your organization. In other cases, you might need to integrate into an existing business process or, create a custom user interface. Identifying that delivery mechanism early in the project and any resources you would need to make that happen will ensure you can quickly begin to recognize value from a machine learning engagement. Okay, so I talked kind of a lot about our project approach. So I'd like to move on, and I'm just going to kind of talk about some projects that we've taken on at Eastman, kind of how our engagement went, why we were or weren't successful. To get that started, I'm going to hopefully play this video. It'll take just about a minute. So Arvid, let me know if you have any problems hearing this.
There's no crystal ball for manufacturing, no magic way to maximize operating time. But when it comes to managing your heat transfer fluid, seeing the future is the way of the future. Introducing Fluid Genius, a powerful digital platform that can monitor, analyze, and extend the life of your fluid, helping you to be more energy efficient and plan downtime with incredible precision. Because if you can measure it, you can manage it. We're pushing the boundaries of optimization, giving you real decision-making power so that you can anticipate the unexpected and predict issues before they become problems. It's not magic, it's genius. Fluid Genius.
Great. And so I love that tagline. It's not magic, it's genius, because you can say the exact same thing about machine learning. It's a lot of people think it's kind of the magical hammer that will solve all problems, but in reality, it's just a tool like anything else, and it only works if you have the right people applying it to the right problem. But as this video suggests, so Fluid Genius is actually an external facing tool, which is very rare that we actually get to work on something that our customers directly interface with. So it's kind of exciting for us to get involved, but it is for our heat transfer fluid business. It allows our customers to get better information from their samples that just kind of help them understand, how's the fluid doing? Are they going to need to replace their fluid soon? So on. And so our involvement with Fluid Genius was around predictive maintenance. And so, with it being sort of an external facing project, it was particularly high profile. It's pretty rare that we roll out any sort of IT solution that would be external. So, we had a lot of resources that were dedicated to this project. It's partially why we had such a successful engagement here. Additionally, we had a lot of subject matter experts who were highly dedicated to the success of this project. I mean, this was something where it was literally written in their performance goals for our heat transfer fluid experts to be engaged in making this IT project succeed. they really helped out a lot with sharing knowledge with our data scientists. So this project team was pretty multifunctional. I was involved with it, so I was working alongside UI developers on the IT side, UI developers, and a lot of database architects who were working to help make sure that the work that I did was easy to interface with the end users of it. We also use sort of the MVP approach here that I mentioned, where we would, regularly set goals, attainable goals of features that had to be available, and we regularly received feedback from users of this application. This solution was also created to replace a previously manual process that our heat transfer fluid technicians did to recommend maintenance. So thus we had a curated data set of thus we had a curated data set of samples that were used to make these recommendations from the past. So all in all, this was a recipe for a successful engagement. We had a lot of dedicated time from our data scientists, subject matter experts. We really had a well laid out plan for, delivering the results to users, and we had a good plan for making sure that we could reasonably attain goals that we had set. Oops, don't want to play that again. There we go. So this is a project that's dear to my heart. It was one of my first big successes under my belt at Eastman. So this project, it's called application modeling. So the objective here is to predict the performance property of a product based on the ingredients that were used in the formulation. So, this might be, based on the material we used, what UV rating could we block for a particular windshield or something like that, a windshield film. So things like that. So in addition to trying to predict the performance properties, we would also want to recommend a formulation to reach a set of target properties. So, a user would be able to say to work with a customer who has a specific need they're trying to meet. They could input their target into this machine learning algorithm, and it would spit them out recommendations to go try in the lab. This project, really the key driver for success to me here was engagement with the subject matter experts. The data scientists involved and our subject matter expert each dedicated at least 50% of their time over several months to this project. I worked on this one as well. By the end of it, I felt like I was well on my way to being a formulation scientist. Our subject matter expert was able to, explain to their colleagues in the lab how machine learning models worked. It was really impressive to see the dedication the time that was allowed for these, the parties involved to work on this project. And while it might not always be necessary to have such extensive time dedication, it can certainly encourage success whenever you're really breaking new ground. This was definitely a new approach for us. So I think that level of dedication really led to the project's success. We also had regular check steps throughout the course of working on this project with the stakeholders who would, make sure that we're moving in the right direction. Typically, this would involve, our data science team sort of sharing progress on the model, what were we able to do with it? How was it performing? The subject matter expert would also help communicate, how that actually transferred into value for them, what new feature were we adding? What did that actually let them take back to the lab? How did it impact the actual users? So, telling value stories like that can be really good for, just just moving the project forward, making sure that everybody's happy with the progress that's being made. And so one of our biggest challenges with this project was data, actually. So even before we began this project, other people at Eastman had spent years collecting and digitizing data for this project. We still ended up with a relatively small amount of data. However, we did have a good variety of different examples of the formulations we were trying to predict. The inputs and outputs were measured consistently, and we had we'd performed extensive analysis to understand like the scope of our data, where there might be gaps in what we can actually predict. So, despite having a little, very small amount of data there, we were still able to, use it because it was good quality data. And we did a lot of work just to make sure that we were narrowing the scope to work with what we had. And it would be dishonest to share success stories without some examples to the contrary. So in this case, we did a proof of concept to detect poor quality products using a computer vision algorithm. So, we would actually have pictures of a product defect, and we would use a machine learning algorithm to actually try and predict if that quality defect was there or not. So, the proof of concept was successful. We were actually able to get a pretty good match with what people were actually doing manually checking these. But unfortunately, we didn't really identify a sustainable way to collect data and deliver the results. So the images we used to train this model were captured manually. But if we wanted to deploy this to production, we would have to go set up cameras in the right places, potentially change the layout of an entire manufacturing line to make this work. It would have been substantial startup cost to procure the equipment, set up any IT infrastructure and so on. So we didn't really consider how to make the project sustainable, how to regularly collect data, make it usable, and deliver the results. So ultimately, we have not taken this project any further than a proof of concept. And finally, I will share one recent example of a project that I actually just wrapped up called SampleFast. So this is a tool that we had created to help analyze the stability of samples that come from our manufacturing processes. And so, in reality, this tool is really more of an automation of statistical methods. It offers a great example of how you can scale a machine learning project up to get value. So we ran an initial pilot of this with one single line in our manufacturing area, and we saw good value from that initial run. We ended up scaling this out to multiple different areas. The labs really saw a lot of value from having accesses to all these different sources of information in one place. And of course, automatically running that stability analysis too was very valuable for them. And since all of our labs tended to use sort of a standard template for their data collection, it was pretty easy to scale this out to new areas. Since we'd kind of proved the concept out in this one area, we had a pretty easy time scaling that to new areas. And really the biggest hurdle in this project was availability of resources to help out with getting the data, despite the fact that it was all pretty standardized in a usable format, it tended to be scattered across a lot of different systems. So we had a need for more resources than we initially expected to really just bring all that data together. And our subject matter experts knew a lot about the data, but not really how the data is managed. They're not IT professionals. They are, chemists. That's kind of what they're good at. They don't know much about how the data is stored. They just use the data, right? So this was really just a learning that, thinking ahead about data management and the resources you need in a project can make addressing simple problems much more complex than we accounted for. Because realistically, most of the time we spent on this project was just trying to bring all the data together. Scaling the solution out was quite simple once we'd figured it out for one area. So with that, I'd like to say thank you all again for having me. I hope that you all found some value out of this. It's looking like we actually went a little longer than I expected, but we do have about 10 minutes for any questions. I would be happy to answer them.
Very good, Bryce. Thank you very much. And you can unmute yourself if you want to ask a question, or you can put something in chat. Don't everybody jump in at once. I'm going to stop the recording if I can figure out which button to push.